Okay, look up. Look at me, please. Okay, anyone here in chamber choir? No. Okay. Okay, so the chamber choir comes by once a week, and they pick up recycling. Everyone knows this, I think. You've seen it happen before. But one confusion is, even though, yes, certain plastics are recycled and aluminum is recycled and et cetera, they're only doing paper recycling. So they're not, so they have to like dig out the other trash and it ends up in the can. So to help them out, to help my sanity, I purchased this deluxe, the word I heard last week was pristine. Yes. Like notice the
the end just kind of ruined it.
yeah, the end didn't quite work. The table ran out there. Notice the inside here. Very nice. It's clean. It feels good. Like, it literally just, it like feels good to just touch. Like it just feels good. It's clean. Yeah, it's brand new. It smells good. Promise. Right? Yeah. Okay. Hey. Look. So I need you to help, of course. So I don't really want any like soda residue to like soil the pristine surfaces of the recycle bins. Okay. No chewing gum, no, just nothing, right? Just paper. Nice, clean paper. Questions? That's it. Cool. Right. I'm very proud of my recycle bin. So anybody want a book on thermal design?
Yes, please.
All right. Is this what you want?
Yes.
Oh, good. See, we made sure it's nice and clean.
Okay.
All right. Okay, next thing. As always, if you did not get through the homework, it's not fair to come to class and ask questions. You just correct that. Thank you. But as you're going through the homework, if you come to class prepared to ask specific questions, you're welcome to do that. Like, I don't think it's not the right mindset to show up to class and go, wait a minute, I think I have a question. No, you prepare yourself before you come. Welcome to college, okay? Did anyone come prepared to ask about anything? No, let's move on. Avery.
So on the front side, the last section that we didn't just finish, 14 through 17, I just, like, at the beginning, I didn't see it going concave up. Like, when I checked my answers, I have no idea how to get to them. Because I mean, like, from the graph, it's just always looking to be going.
You're good. So you're referring to the fact that the position graph in blue looks like from time equals 0 to be concave down. Is that fair?
Yeah.
Is that
and
true?
then I had the maximum. I probably just messed up.
You're okay. Don't worry about that. That's not, Avery, that's not the part I care about. I just want to make sure I'm thinking how you're thinking. So you're thinking that when I look here at this blue graph, I see concave down. Awesome. Eyes on the board. Don't miss this. It's really a superb question. 2 points. It's a really good example of an AP test question where they make something just tricky enough to make you feel confused. And even with the answer, you still feel a little confused. That's classic AP. Because they gave you a calculator on this problem, they knew they would allow you to look closer. Okay? Without a calculator, they're maybe not quite as tricky. But I don't even really need the calculator. So the key question is, we're supposed to figure out when, from time equals 0 onward, is the graph of position concave up or concave down. Avery's right. Looking at position is not very helpful. So I need to look somewhere else. So this is where I look. Yeah, look at this chart. If I assign this column to be position, that means this column must be velocity and this column must be acceleration. Any questions there? Awesome. Okay, it's hard to see the position right here. it's almost as hard to see the velocity because they're both really flat. But the acceleration is pretty clear. So without even looking at position, I note that initially the acceleration has positive y coordinates. Right here, positive y coordinates. So without even seeing the position, I know for certain that position graph has got to be concave up in that region. So even though it's very hard to see, what's really happening is the position graph is concave up, remains concave up until right there. The exact moment when the acceleration y coordinates become negative, that's the inflection point. That's where the change occurs. Did that help?
Yes.
And that's how they expect you to recognize it.
Okay, yeah.
Good work. Anybody else? Bring a question to class. Cool. So grab the yellow packet that I gave you last time. Okay, the wording on the yellow packet can be a tad confusing. So let me just give you a couple of hints to make sure that you don't get stuck on the wording. So number 1 says, which of the following graphs, A through D? One thing, hey, you'll hear me say this a lot. You cannot read fast in AP Calculus. Like one of the most common reasons people miss questions is they read too fast. It's not AP US History where reading fast is an advantage because you got to kind of get through a paragraph quickly, get the general sense of the, the paragraph. Here you need to read really, really slow. So which of the following graphs A through D? Therefore, which of these down here? Which of these could represent the slope at every point? So key phrase, slope at every point of the function graphed here. So what they're saying is this is a function, call it f, call it whatever you want. This is f, and one of these graphs, every y coordinate is representing a tangent slope of this graph. Well, that's what f prime is. F prime is a graph where every y coordinate on the f prime graph is representing a tangent slope of this f graph. That's what f and f prime mean. You need me to say that again. So they're giving you f, and you're supposed to find f prime by matching. Question. Okay, just so you don't get mixed up, I'll just run through them quick. Number 2 is the same thing. They're giving you f, they're looking for f prime. If you want to make notes, feel free. You go to number 3, same question again, they're giving you f, you're supposed to find f prime. Number 4, same thing. 5, same thing. 6, same thing. 7, they switch it up. So the wording is nearly identical in 7. The wording in 7 is nearly identical, except that it says, which of the following graphs, A through D, so which of the graphs below, could represent the function. So now this is a function whose slope is graphed here. So now they're giving you f prime, and you're supposed to find f. And that goes on for a few more problems. So 8's the same way, f to f prime. 9, same thing. Sorry, I said it backwards last time. F prime to f. 10, I think, is the same thing. I forgot to scroll. Yes, f prime to f. There's some different problems here for a minute. We'll not worry about those. 17 is actually f to f double prime. 17 and 18 are f to f double prime. I think you're good from that. So we're going to talk together for a minute about problem number 6. So we're going to talk about problem number 6. And let's put, so this is F. And we're looking for F prime. There are different ways to solve the problem, but the way I solve it is I first look at the easiest points to identify on F. And the easiest places to look on F, what is it, locked? Sorry, people beating on the door of the office. Okay, Allison.
Sorry, fall over.
So the easiest thing to do is first identify where on F are there any tangent slopes that are equal to 0. So I want you to think with me. Now, because they didn't give you a calculator to like regraph it, zoom in, that sort of thing, if you see a point on F that appears to have a tangent slope of 0, it probably is. They're not going to try to trick you that way. So look at this and just show me with your hand. Do you see no places on F that have a tangent slope of 0? This is one spot on F that has a tangent slope of 0, 2 points on F that have a tangent slope of 0. Show me with your hand. How many points on F do you see that have a tangent slope of 0? How many points on F have a tangent slope of 0? Just vote with your hand. A few non-voters protesting the democratic process. Okay, let me give you a hint. A tangent slope of 0 means that if you were to draw the tangent, you would see a horizontal line. A spot where the graph is not going up, it's not going down. Because slope is representative of how fast something's changing. And if the line is flat, the output's not changing. So show me, how many points on F have a tangent slope that is equal to 0? If you're doing this, give yourself 3. So if you're doing this, give yourself 3 as well. So it's a joke. Right here, look. Tangent slope of 0. Tangent slope of 0. Tangent slope of 0. Question. You need me to talk through it again. Outstanding. All right. That means that at about x equal negative 1.5, at x equals 0, and at about x equal positive 1.5, I would expect to find y coordinates on the graph of f prime that are also equal to 0. That's the correspondence. Every y coordinate on f prime is representing a specific tangent slope on the graph of f. I found 3 tangent slopes on the graph of f that are easy to identify. Therefore, I should be able to find 3 y coordinates on the graph of f prime that are just as easy to identify. So you're going to show me. We got 4 choices. How many of them work so far? 1 of them, 2 of them, 3 of them, or 4 of them? Show me. So far, how many of those graphs are still possible answers? So here's the key. Here's f. This tangent slope right here at 1.5 is a tangent slope of 0. So I would expect to find down on one of these graphs at x equal 1.5 negative a y coordinate that is equal to 0. So that one works. But I also have to find a y coordinate of 0 here at x equals 0 and x equal 1.5. So how many of these? 1, 2, 3, or 4. Both like this so that people can't see. 1, 2, 3, or 4 are possible answers. I know you can look around, but it helps to have you thinking instead of just watching. So way too many points to give away, but if you're doing this, give yourself 4. So. And as always, the key here is not to watch what I do, it's to understand what we're talking about. So So is there anything about what I've been saying, not what I'm doing, but what I'm saying, that is not clicking in your brain? It's just not feeling good at anybody. Please.
So like on the answers, if it touches 0, doesn't go through, that still counts.
Well said, Cass. Yes, because the whole idea is right here, this point has an x-coordinate of 0 and a y-coordinate that is also 0. And what that means is if I go back up to the graph of f, when I get to x equals 0, I should find a tangent slope of 0. So it doesn't have to cross, just equals 0. Is that your question?
Yeah.
2 point. Moving on. So all of them work, so we have to find something else. So Danica Wright to the rescue here.
Danica Wright? Oh, that's pretty cool.
It is Danica Wright, yes. Allison knows of Danica Wright's fame, and so. Anyway. So write this down real quick. Remember, no notes, no cards, no helps, no nothing on the test. So, and if you wait until the night before to memorize things, you are really in trouble. Because if you're trying to remember what you memorized the night before, your brain can't relax and just solve the problem. So get it memorized now, don't wait. What I did in college is I always tried to memorize as I was doing the homework. So yeah, I start out using the reference, but then once I've used it, like on the next problem, I try to do it without the reference. If I have to look and verify, that's fine, but I have to get myself memorized as quick as possible. So memorize as you're doing the homework. Okay, we're looking to go from f to f prime. I can choose to look at this characteristic of f or this one. It doesn't really matter. So I just start, I don't really care, I'll start here is fine. So I look at f, and I notice that f is initially increasing because f goes up. So from -2 to -1.5, f should be increasing, which means from -2 to -1.5, f prime should have positive y-coordinates. So show me with your hand, this is A, B, C, D. Just show me one of the graphs that would work. One of the graphs that would match that, just that characteristic. The fact that from -2 to -1.5, f is increasing, therefore f prime must have positive y-coordinates. So show me A, B, C, or D, which of those 4 works? There's more than one that works. I just need to show me. I have to find out myself. We'll just pay for voting on this one. So if you voted, you get a point. This one didn't work. These y-coordinates are negative. These y-coordinates are negative. However, these y-coordinates are positive. And these y-coordinates are also positive. The negative positive is not meant to be any reference to local universities, so never mind. Okay, I thought that was a decent joke, but it apparently was not, so I'll delete that from my repertoire or try it on a different period. So, questions? Awesome. I just got nervous. Like blue is negative, red is positive. Like somebody's going to get upset. So, okay, never mind. Question. So these two don't work. Anybody need me to repeat why these two don't work? Awesome. Just keep checking. Let's see, from -1.5 all the way to positive 1.5, f is decreasing. Therefore, f prime must have negative y-coordinates. There will be one spot where f prime won't. That's right here. We already identified that. There will be a spot where f prime has a 0. But otherwise, f prime should be negative from -1.5 to positive 1.5. So show me with your hand which of the final two answers work. Oh, there we go. See, I'm kind of brain dead. I have to do it the simple way. A, B, C, D. So that's all. It's not your fault. You're doing, I couldn't see it. So. If you're doing this, give yourself 3. So. Any part of that bothering anyone? Questions? You want me to do it again? Just wave. Perfect. Next thing. Go down to number. So you get some practice on that in the yellow packet tonight. Go to number 9. Okay, number 9 turns the problem around. So now they're giving you f prime, and you're supposed to be identifying f. So I start the same way. Now the points on f prime, all of those points represent tangent slopes on f. So every one of these y-coordinates is representing a tangent slope on f. Well, again, the easiest tangent slopes to identify are the horizontal tangents, where the tangent is equal to 0. So when I look at this graph, I immediately identify points on f where the tangent slope should be equal to 0. So I want you to vote again. Show me with your hand, by looking at f prime, how many points on f will have a tangent slope equal to 0? No points, 1 point, 2 points, 3 points, vote. How many points on f will have a tangent slope that is equal to 0? This means 0, this means 1, this means 2. How many points on f will have a tangent slope whose value is 0? If you're doing this, give yourself a point. What is the x-coordinate? Hey, what is the x-coordinate on the graph of f where the tangent must be 0? Show me. What is the x-coordinate on the graph of f where the tangent slope must be 0? What is the x-coordinate on the graph of f where the tangent slope must be 0? Doing this, give yourself 3. That point right there is x equals 3, y equals 0. As I always say, you've got to know the meaning. When you look at this graph, you can't just say, oh, I get it, 3, 0, big deal. No, you've got to know that that means the x-coordinate down here is going to have a tangent slope of 0. So, vote. Do any of them work? There's more than one, just show me one of the 2 or 3 that work, or 4. So show me one of them that still work. A, B, C, D. Show me which one works, or which. You don't have to show me 2 of them if you don't want to, but that's a good idea. Let's do 2. 2 of them work. Show me with 2 hands which are the 2 that work. Which are the 2 that work? The Great Friday Ticket Giveaway, obviously. So again, this is a y-coordinate. Sorry, yeah, it's a point, 3, 0. So at x equals 3 down here, you're looking for a slope that is horizontal. Show me. Which of these work? 2 of them work. Which 2? Two hands. Which 2 work? If you're doing this, give yourself 6. People are what, 42? Question. If you look here, this tangent slope is negative. That's not a tangent slope of 0. That's x equals 3, but the tangent slope's wrong. The tangent slope is supposed to be 0. This one doesn't work either. These 2 work. Question. you need me to repeat it, just talk through it again in different language. Not different languages, different English words, so I would struggle mightily to talk to it in a different language. But time for a joke, apparently. So, you guys can help me. What do you call a person who is person who speaks two different like English and Portuguese? Bilingual. How many have heard the joke? Oh, okay. All right. It's decent. It's decent.
It's a good one, yeah.
It's a good one. Clever. What if someone speaks three languages? You know, English, Portuguese, Spanish. What do you call that? Outstanding. My son-in-law, sorry, got that. My son-in-law, he grew up speaking Spanish because both of his parents immigrated from Mexico. He served an LDS mission to Brazil to learn Portuguese for his mission for 2 years. And then just because he thought it would be fun, he just learned French on his own. So he actually last year taught Spanish, Portuguese, and French at Skyridge. So I'm proud of my son-in-law. I have to brag a little bit. What do you call someone who speaks lots of languages, like my son-in-law? Say
Multilingual.
multilingual. What do you call someone who speaks one language? American. Okay. Kind of true, unfortunately. Never mind. Okay. Decent. We're great television. I don't know what we're talking about now. I distract so easily. Hold on. Let me reset. Okay, got it. Look up. Okay, so we got to go to here now. Dennis' chart again. But I hit what? Okay, it's AP. They love to give you questions where suddenly you're like, wait a minute, I'm confused. Okay, get used to that feeling. It's normal. You're not supposed to look at a test question and say, I know there's one I did that's like this. If you do that, you're not going to do well on the AP test. You don't think that way. You think of it in terms of, no, wait a minute, what's the concept here? I've got F prime I'm supposed to find out. So don't search your brain for a previous problem. You probably won't find one. Search your brain for concepts. Okay? Let's see. Increasing problem here. This graph is increasing from 0 to 3. So is this one. Not helpful. This graph is decreasing from 3 to 6. Same, not helpful. Both graphs are always concave down. No difference as far as Danica's chart is concerned. So the characteristics illustrated here don't help. Okay? So you have to think of something else. Well, fundamentally, every y coordinate here is a tangent slope down here. So I need to go find some tangent slopes. I already found this one. Let's find another one. So just because it's easy to identify, right there, I can draw a tangent. So not very good. Let's try again. That's nearly dead on. Not well, good enough. Okay, I'll try to accept it. Kind of like the can. I like it to look nice. Anyway, tangent slope. So I need to find that slope. So I just look at it. Slope means rise over run, and I say, let's see, from here to here. So just say it, please. From this point to this point, the rise is the output. From this point to this point, how much does the output change? Say it. Try again. From this point to this point, how much does the output value change? Still hearing the wrong answer. From this point to this, what's the y coordinate here? Say it.
1.
Better. So from here to here, how much does the y change?
1.
There we go. 1. That's how much the output changes. This is what slope means. Slope means change in output compared to change in input. So the output changes by 1. During that same span, Look here. Say it. How much does the input change?
2.
It's kind of dumb for me to sit there and point at 2 and ask how much does the input change. But whatever. Okay, so the slope is 1/2. Anyone need me to repeat that thought again? Because it's not what I'm doing that's important. It's what I'm describing that's important. The idea, questions. You need me to repeat it just way like this? Cool. Awesome. So at x equals 0, the graph of f has a tangent slope of 1/2. At x equals 0, the graph of f has a tangent slope of 1/2. So raise your hand if you know. What should I be finding on the graph of f prime at x equals 0? Raise your hand. Come on. Show me. All who know. If at x equals 0, on the graph of f, the tangent slope is 1/2, what should I find up here on the graph of f prime at x equals 0? This is the key concept that you must understand, is how those two things tie together. Weston, what is it?
What x equals 0 mean? The x0, whatever, it's 3 on there.
You're okay. So I'll say it back to you. You've got it. Let me
Yeah.
say it back to you. So here, at x equals 0, the tangent slope is 1/2. That means up here on f prime, at x equals 0, I'd better find a y coordinate that's 1/2. And I don't. The point would have had to have been here. It is not. These do not match. These do not match. I mean, you knew it before he said it. Point. I'll wave if you want me to go through it again. Ready? Cool, very good. Just for emphasis, if I came down here and did it again, so I must practice drawing my tangent lines. It's my only talent in life. Decent. Show me on your hands. From this point, this is how you calculate slope. You go from point to point, from this point to this point. Show me on your hand. How much did the output change? Show me. From this point to this point, how much did the output change? That's what slope means. That's what average rate of change means. Give yourself 3. The input changes by 1. Slope is 3. And that's what we find. If x equals 0, we get a y coordinate that is 3. That's a perfect match. And because it's just a matching exercise, I don't need to find more. I found the one that works. So, Weston, please.
Another way that I found it was I did the displacement area of the first graph.
Wow.
And, you know, like
I know what you're talking about. Yes, for sure.
And then you sets with it.
Totally valid.
Yeah.
For the rest of the room, we didn't. 2 points for Weston. If you didn't know what he's talking about, don't worry about it for now. So, no big deal. It's a perfect way to do it. We don't learn about that for a while, so you're just perfect. It's all good. It's a physics concept, so if you're talking physics, that's what you're talking about. Yeah. We learned it in January, so it's all good. Anybody else? Yeah, don't hesitate to speak up, though, because it works perfect. It's awesome. Okay, next thing. Let's keep moving here. You go to number 11 is pretty straightforward. Let's talk about 10 for just a second. Make sure you don't have any confusion. Sorry, 12. In fact, well, just to make sure there's no confusion about the question. 12 says, in this figure, the second derivative at points A, B, and C is what? Well, note, they're not showing you f double prime. They're showing you f. But you're supposed to look at f and figure out if f double prime was in the picture, what would we be seeing at point A, B, and C? So it's a Danica's chart problem again. You've got f prime doesn't really matter. F double prime is important. So really, between these two, if you look at the chart on the wall or on your handout, the only correspondence is right there. That's the only thing I have to worry about. So if I'm trying to look at f and answer questions about f double prime, I'm paying attention to the concavity of that. I'm paying attention to the concavity of that. So do that one. I'll just walk the room, find the answer, then I'll ask. Go. Feel free to talk to each other. It's fine. Just be careful. When you talk to each other, working together is absolutely great, as long as you ultimately are doing your own thinking, because you're the one who has to take the test. So, go. No, not at all. So what you're looking at, come around over there. What you're looking at is that line graph. The y coordinates are representing the slopes of the f graph. Yeah. So right here, what's the xy coordinate of that point? So come down to here, so go to x equals 3, and y equals 3. Find the graph right there. So that's a perfect match between those two points. Does that make sense? Right. It's just how f correlates. Every point up here, to find the correct match, every point must match. I'm just looking for enough points that match the graph. So I can look here and say, okay, according to this picture, when x is equal to 6, what's the slope of x? So this is the graph. I didn't show you this right now. That's the point. You're the one that has to understand how they relate. So if I ask the question of the graph of f, what is the tangent slope of f when x is equal to 6? How would you answer that question? So I would do something different. I would say, this graph tells me what the slope of that is. So I go to x equals 6, find the point on this graph. That's 6. I can tell you with certainty that this f prime, whatever happens, let's create this f prime, that graph will have the slope of
So for this to be right, what would the x bar?
So I go over here and I say, okay,
I haven't done that one there.
Okay, so what did,
so that's the problem. Because that means if these two graphs really do match.
is it like flattened out? You know that's flushing where it changes? It's like, okay, sorry.
Okay,
Show me on your hand the answer, please. Show me on your hand. A, B, C, D, E. The trouble is, it's like, I guess if I took the mental, yeah, it would probably be better.
This works.
But this is faster for me who doesn't, I'm not bilingual, I'm American, so. I did speak Portuguese once upon a time, reasonably well. Everyone's saying B, I hope it's right. Did anybody check the answer in the back? Give yourself 2, please. You don't have any part of it though that like kind of puzzles you, you're wondering about anything. Just please.
Can we just go over like how you know when it's concave up or concave down again?
So, visually what I'm looking for, Danny, is this. A curve that has this shape, or any part of that shape, is concave down.
Okay.
So because this section is definitely kind of like this section, I know this much here is definitely concave down. So I'm very, very confident that at x equal a, the y coordinate of f double prime, the value of f double prime, will be some negative number. And so I'm really comfortable that it's got to be this one of these 3. You good there? Anybody else questions?
Yeah, that makes more that makes
Is that pretty much?
Yeah,
Okay.
that's fine.
Very good. Anybody else? Awesome. Keep going. So that problem's pretty similar. I'll let you do that as homework. Very similar again. 15 is a little different. Let's look at that. The printing here, not as good as it should be, at least on mine. That's x equals 0. That doesn't look right on yours. Okay, so now it says in this figure at x equals 0. So I'm not looking anywhere but right here. That's the only place I need to look. The signs of the function and the first and second derivatives. So this is definitely a Danica's chart problem. And get this memorized as quick as you can, so your brain can focus on problem solving, not memory recall. So they want to know, here's f. It's kind of like this, really, where you go to a certain point, like x equal 2, or let's go to x equal 3, and you say, on the graph of f, here's f, and you're supposed to figure out what f prime and f double prime are, but you don't have any picture to look at. All you have is down this chart. But you can still do it, so do 15, go. Stop me if you're uncertain or want to talk. First thing I would think is this, sign of the function. So when we talk about a function, the values are x's and y's, but usually they're talking about the y's. The x is just telling us where that y happens to be located. So right here, would you say that the value of the function is a positive number, or is the value a negative number? So that means it's got to be one of these two. sine of f itself is positive. It does. And now down the chart comes into play. All you have to look at is f at this point. What characteristic of f will tell you the sine of f prime? So if f is increasing, then the sine of f prime will be positive. The sine of the y coordinate. And then the last one would be what characteristic of f indicates the positive or negative of the double coordinate. Cavity. Have to be positive. So that's why. It's a strong way of thinking about it, only from the standpoint of you don't want to think of, hey, every time I solve this problem, I just go 1, 2, 3, because you won't get that problem. What you want to connect is, oh, if I'm trying to understand, can I talk on the board for a second? If I'm trying to understand something about f prime, and all I have to look at is f itself, and I want to know, like, go back to this picture again. Okay, look at this point, and let's pretend we can't see these two. So what that question is really asking is, if all you can see is this point, I picked one that's really hard, let's pick an easier one. This one. All you can see is this point. Can you figure out whether f prime has a positive or negative y coordinate at the same x? So this is x equal 4.5. And if I can't see this, I can still figure something out. I can say, hey, right here, f is decreasing. So that means the y coordinate on f prime would have to be a negative value. I wouldn't be able to tell how negative necessarily, but I can at least say that it's negative. Does that make sense? Anybody else? Oh, please.
Question. How do you know if it's positive or negative if you're looking at x at 0?
So let's go back to here. Say it again.
So our x is at 0, so how do we know if it's increasing or decreasing? We look at what's around it.
Well done. So right here, f. F has, everybody, hey, the graph of f at this point has 3 key characteristics that you have to be able to recognize. The first characteristic is the y coordinate has a positive value. Does that make sense? Mm-hmm. Good. Second characteristic is the y values along there are decreasing. So you're not really looking at just the point, you're looking at the 2 on either side as well to see, oh yeah, they're going down. And then the third thing you're looking at is the curvature. So concave up. Is that your question? I'm not sure if I'm helping.
Yeah.
Sure.
Yeah.
2 points for Rachel. Please, no.
Is that the order it'll always be?
Say it again.
Is that the order like it'll be as because it says like in order, so you were talking about you find like the point first and then.
I got distracted trying to figure out who it is. Right?
Yes.
It's kind of blurry with my glasses on. Say it again, no, sorry.
So you're talking about like find the signs in order.
Oh, let me say that back to you. Gotcha. Signs in order is simply referring to, they said you want to find the signs of the function, the first derivative, and the second. So they gave you the order. It's not that they would always ask that order. They gave it to you. They said, hey, first of all, figure out the sign of the function. Meaning this point has a y coordinate. Is that y coordinate positive or negative? Positive. So I've done this one. Now go figure out what would be the sign of the y coordinate on f prime. Is that your question?
Yeah. That
2
makes
points.
sense.
Anybody else? Smooth. Okay, cool. Next thing. Keep moving. I'm going to leave that up to you. I think you'll be all right. And those up to you as well. Okay, the next section, starting at problem 21. And you'll get used to my kind of documentation style. I said many, many times, I want to help you get used to, like, help you learn how to solve AP problems. So you can always tell when I'm giving you an old AP problem, because I list the test right here. So this is a 1969, it's been a while. I was 4 years old at the time, so came from the AB test. The actual problem number was 16, and then I've just renumbered it for the packet. So does that make sense? Okay. Skip that one. I think you're okay there. Skip that one. Let's do 23. So we'll do 23 together. Okay, again, reminder. There are AP problems that you will read, and your brain will say, oh, I've done one like this. Hallelujah, celebration, go for it. But there will be a lot of AP problems that you'll read, and your brain will say, haven't done one like this. Don't worry about it, just go back to the concepts. This problem was given on the BC test. The BC test has a lot of AB questions, so I often pour through those tests to give you more exposure. But anyway, the BC test given in 1985 had this question. I have never seen one like it previously since 1969, and I have never seen one after it that's like it. So it's a great example of how good the test writers are at creating unique problems. They'll do the same in 2019. They'll come up with new stuff you've never seen before. So just read slow and careful. F is a function. Nothing new there. I deal with functions all the time. That is continuous. Now that word is really important. I'm definitely going to circle that. On the closed interval, -2 to 3, I stop and notice, okay, closed interval just means they don't care if I look beyond that. I just look from -2 to 3. But as I glance at the graphs, I'm like, oh, that clue really isn't that helpful because all the graphs are from -2 to 3. So whatever. Here's a new clue. Such that f prime of 0 does not exist. Okay, this is extra credit, tickets, points, I mean. Raise your hand, ignore the does not exist part. Just raise your hand if you know, what does the symbol f prime of 0 mean? Hands up. The point of this class is to make sure you know the meaning of the symbols. If you know the meaning, you're doing great. If you've lost track of the meaning, you're on the wrong track completely. So what does the symbol f prime of 0 mean? If you guess wrong, it's fine. What does the symbol f prime of 0 mean? Isaac?
It's like the velocity at x equals 0, or like kind of the slope, I guess.
Let's start with that. It's really well done. So in all of our discussions for the last few days, we've been talking about position, velocity, acceleration. And so if f were the position function, Isaac would be perfect there. F prime of 0 would be the velocity at time 0. Absolutely. If you were thinking that and you had your hand raised, give yourself a point. What's another way to describe the meaning of, like throughout the velocity position kind of idea, what's another way to describe the meaning of f prime of 0? Hands. What's another meaning of the word f prime of 0? Maddie?
It's a tangent slope of this function at 0.
Perfect. So when I see that symbol, I literally read the tangent slope of f when x equals 0. The tangent slope of f when x equals 0. You had your hand raised, you were thinking that, give yourself a point. So this clue, you may need me to say it again. Okay. So the first part of it is just a memorized fact. The y coordinates on f prime, they're just a bunch of numbers, but every one of those numbers represents a tangent slope of f. So f prime of 0 means at x equals 0, in fact it means two things. If you were looking at the graph of f prime of 0 means go to x equals 0 and find the y coordinate. But if you're looking at the graph of f, it means go to x equals 0 and find the tangent slope. So f prime of 0 means two things. Elijah?
Would that be the same thing as the derivative?
Absolutely. F prime of 0 means the derivative of f at x equals 0. Because derivative means tangent slope. Derivative means instantaneous rate of change. Perfect. 2 for Elijah. So this one says f prime of 0 doesn't exist. So translate it. Raise your hands. If f prime of 0 doesn't exist, what does that mean for the graph of f? Hands, come on, translate it. If f prime of 0 does not exist, what does that mean on the graph of f? What do we expect to find on the graph of f, Sarai?
That there won't be like a regular slope at x equals 0.
Say it again.
There won't be a regular slope at x equals 0 like any like.
That's good enough. It's perfect. It's perfect. She's thinking, hey, if I look at the graph of f and I go to x equals 0, I'm not going to be able to find a tangent slope. That's what that means. Hands up if that's what you would have said if I called on you. Show me. I got to see how we did. Point. Well done. So here, look. We talked about previously that if I'm trying to find the tangent slope at x equal a, the way I do it is I draw secant to the right, secant to the left, and then I shorten the secants until they are infinitesimally short. And when I do that, they're so close together it starts to look like one line. And that line slope is the tangent slope. Got it? Here's the problem. This graph here, actually that's not the best printing because it was 1985. That graph really looks like this. Okay, it's a very sharp point. It's what I call a corner. Comes down, changes like that, okay? If I were able to put this on the software where I can draw the secants, you draw secant to the right, left, secant to the right, and then you shorten them. It will not matter how short you make those secants, they'll never do this. They'll always look like that. No matter how much you shorten them, they'll always come to a point. So we can't find a tangent slope at a corner. Please.
Can you explain to me how D is continuous if there's a jump between the two lines?
Oh, gotcha. D is not. So with that clue, I can eliminate this.
Okay.
Perfect. 2 for Elijah. You guys show something else here, though. Anybody else? So this graph does not have a tangent slope at x equals 0. Please.
On the, would it have the same thing on B? So it looks like there's like a point there too.
Yeah, again, the printing's poor, but it's exactly what you're seeing, Danny. It's going to look like this on B. Come on, Ben. Like that.
And would it be the same on like E as well?
Nicely done.
Okay.
E has this kind of appearance. Perfect.
Okay.
This one here, you can't find the tangent slope at 0 on this one either, because if I put a point here, and I go secant to the left, and secant to the right, when I try to bring those slopes in, they're not the same again. They're very different. So I can't find the tangent slope here either. Okay, questions? Awesome. So we've eliminated this one because it's not continuous. We've eliminated this one because this one does have a tangent slope. So we're down to 3 possibilities. And we want to re-talk through those. And again, remember, we're not trying to learn how to do this problem. We're trying to learn all the concepts associated with the problem. I can guarantee you there's not one like this on the test I will give you. Is there a problem on the test that expects that you understand continuous? Yes. There are many problems that expect you to understand what f prime of 0 means. Are there problems that expect you to understand that you can't find a derivative here or here? Yes. Just not this problem. So, please.
Sorry, this doesn't really apply to this question.
You're good.
But like, dude, on the one with the jump, right, you said you couldn't find it because the slopes won't match. So if you had one that had, like, let's say the slope of 2, like positive 2 on the left, and then there's a jump, and then there's continued with the slope of 2, could you find, like,
super smart.
would it be possible to find the
3 points for that. Super, super smart. my little analogy of drawing the two little secants breaks down there. You still can't mathematically find the derivative at the jump, even though they do match. So,
Okay.
yeah, that just doesn't, anyway.
Okay.
Oh, I have a better answer though. No, I stand corrected. It's actually this, Danny. Sorry, I was thinking incorrectly. What you're saying is this. What if I draw a graph that has just steady slope of, we'll say 1. And then the graph jumps to here
Yeah.
and continues with a slope of 1. Mathematically, the way you actually compute the slope is different than what you're envisioning.
Okay.
So mathematically what you do is you create a secant here, and that secant slope would definitely be 1. No matter how close I move that dot, the secant slope will always be 1. But I'm trying to find the slope from this point. So the other secant has to go all the way up to here. So it ends up like this. And then as you move that down, the secant moves with it. So no matter how close I try to get, that slope won't ever match that.
Okay.
So still no. Question? Does that answer your question?
Yeah, it does.
Good. Anybody else? Solid. Back to here. Got 3 choices left. Keep reading. F prime of 2 is supposed to equal 0. Raise your hands if you can interpret that. What does it mean to say F prime of 2 has to equal 0? Show me hands. You can interpret what F prime of 2 means. You guys are really doing well. Like everyone's just getting in the whole spirit of it. Doesn't matter if I'm right or wrong. Raise my hand, see how it goes. So what is it, Mike?
Tangent slope at x equals 2 is 0.
Tangent slope on the graph of F at x equal 2 is 0. Perfect. So I come over here and say at x equal 2 is my tangent slope equal to 0. Yes. Yes. The AP test writer is just laughing and laughing. Yeah, you suckers. Okay. Didn't help a bit. So, how many were thinking that? Point. You would want to talk about it more. Just wait. Awesome. So that clue didn't help. It's okay. Just keep going. F double prime. That printing again is a little poor. Sorry. So F double prime is supposed to be less than 0. F double prime is less than 0. So F double prime is negative for all x except x equals 0. So raise your hand. The clue telling that F double prime is supposed to be negative tells me what about one of these graphs of F? Hands, please. Come on. If I see that F double prime is negative, what does that tell me? Danica's chart again. What's that telling me, Rebecca, about the graph of F?
Then that means that has to be concave down.
How many knew it? Point. This section right here, concave up, that doesn't work. This section, concave up, doesn't work. Here we go. Concave down, we're good. You want to talk more about it? Please, Wesley.
So wait, why?
You're good.
Oh, okay, I see, never mind.
You're okay?
Yeah.
2 points for asking. Anybody else? Please,
So that
Matt.
corner, that would make concave up right there, because that doesn't exist.
Right there.
Yeah.
Great question.
Short concave up.
2 for Matt. Everybody watch this. Watch. Look, look, look. Here's what she's referring to. The graph that was the winner, the correct answer, looked like so, correct?
Yeah.
Okay. The clue said this graph of F will be concave down everywhere except x equals 0. So not concave down at the point. Here's why. Just say yes or no. Can I find a tangent slope at that point? Say it, yes or no?
No.
No, good. So if I were drawing the graph of F prime, the graph of F prime at x equals 0 would have no point, nothing. So when I go to draw the graph of F double prime is the tangent slopes of this one.
Yeah.
So at a missing point, I can't find a tangent.
That makes sense.
So actually on the graph of F double prime, there's just nothing there. That's why they say that.
Thank you.
Perfect. 2 points. Anybody else? Awesomeness. Okay, that's not a word. Let's go. Keep going. Sweet. This one I remember now. We need to talk about this. (28). Welcome to the unique world of the AP test. Once again, I will tell you, I've looked at every multiple choice test that has been made public since 1969, all the way through 2018, plus about 6 of them that haven't been made public. They're just accessible to teachers. There's never been a problem like this ever, except for this one. But there have been problems that use the same concepts, okay? So here we go. Particle starts from rest. That's simple. That means the velocity is 0 at time 0. So you see the word rest, starting from rest, you go, oh, velocity at time 0 equals 0. So I just write that down as a clue. Keep reading. Particle starts, losing my voice, sorry. Particle starts from rest at the point 2, 0. This is where people get mixed up. When you look at a graph, you are not looking at the particle. Just stop looking for the particle over here. I hate when people explain like, oh, here's the particle. You can see it. It's going this way. Like, you can't see anything. It's just a bunch of numbers over here. A graph is just a bunch of numbers, okay? No particle. There's no particle here. Ever got it? Awesome. Particle starts from the point 2, 0. Okay, they're describing a completely different situation. Somebody last period, I thought, said it nicely. They said, oh, think of the particles being on a table. Okay, so here's the table. Draw a grid, not a graph. This is the graph. I'm just drawing a grid over here. Got it? Okay, on this grid, I have to draw it up here. So this is your tabletop. The particle is going to start at the point 2, 0. So the particle is going to be right here. I have found the particle. Not the graph. It's over here on this grid. Different. I'm using different words on purpose. Okay. This is where the particle is located, and it's going to travel along the x-axis. So the particle is not going to go this way. It's not going to go this way. It's going to go along the axis, and that's it. So it's identical to what our discussions have been for the past few days. Just back and forth. Anyone want to talk more about that? Awesome. Keep reading. Constant positive acceleration. So the acceleration is constant and positive. Constant just means doesn't change. So maybe the acceleration is +2. Maybe the acceleration is +5. But it doesn't change. Next thing. Which of the following could be the graph of the distance s of t of the particle from the origin? How far away is the particle from the origin right here? Say it. 2. So graphing the distance from the origin is the same thing as what I call position. It's no different. Position is 2 from the origin. Same thing. So they're using s of t. When we discussed, we used x of t. Same thing. We're pretty good? Awesome. One of these graphs is the correct graph. So we have to start eliminating. Okay, now we're looking over here. You do not see the particle anywhere here. The particle's over there. Okay? What you see here are just a whole bunch of numbers. Remember, it's just a bunch of points. And every point has 2 numbers associated with it. So look at this one. The 2 numbers associated with that point are 0, 2. What does the 0 here mean? Raise your hand. Come on. What does the 0 mean? Hands. Hands. What does the 0 represent in this graph? It's a graph of position. It's a graph of position versus time. So what does the 0 mean? Right?
The x coordinate is 0.
True. And stay with me. And on a graph of position, what are the x coordinates representing?
How far it is.
2 points, but no, it's okay, don't worry, mistakes, no big deal. What are the x representing? Hey, time. So, yeah, you remember now. So on a position graph, this is time. So this says time is equal to 0. How many knew it? Point. What does the 2 represent? Come on. On a position graph, what does the 2 represent? Ellie?
Position.
Position. How many knew it? Point. So when time is equal to 0, the particle should be at grid location 2. It is. At time equals 0, the particle is located at location 2 along its path. Question. This is a match so far. Question. Matches perfectly. Somebody asked me a really good question last period as well. They said, what are the units of this? And I said, well, they didn't give me any, but common units would be seconds and meters. Okay? Then they said, well, what are the units of these two numbers? I said, they're both meters, because they're describing a location. Particle is over 2 meters and up and down no meters. That's the location of the particle. This is a graph of the particle's movement. It's different. Very good. Awesome. Keep going. So these don't work. These are saying right here, when time is equal to 2, the particle should be at location 0. We don't have any idea if that's true or not. So those can't be right. Questions? Oh, please. So this point is 2, 0. Good to there. What does the 2 represent? Time. What does the 0 represent? Position. So if the time were equal to 2 seconds, we'd expect to see the particle over here sitting right here. And maybe it ends up there, but we don't know that. This means at time equal 2, the particle will be located at that time at 0. You good now? Yeah. 2 points. Cool. Keep going. The only other clue I have is right here. But Danica tells us, not really, but we'll give her credit, that if the acceleration is positive, raise your hand if you know what do you know about the position? Hands, come on. So if acceleration has to be positive, Camry, what do you know about the position?
It has to be concave.
Position graph will have to have a concave up shape. It's the only one that works. Question. Elijah, please. Okay. The phone will ring in about 1 minute, 30 seconds probably, 15, 14. Okay. Look, this is the homework, okay? Warning, a huge warning. Don't do this. Watch me. Do not do this. I have nightmares of you doing this. Don't do it. You read the problem. Don't go. Then you go D. Yeah, I see that. Next one. Okay. The only reason you look at the answers is like final confirmation. I can't really stay after school today to help because I got to drive to Logan to help my son. Sorry. But I will try to clear my schedule to be early on Monday and really late on Monday if you need us.
Wait, on this one?